Good morning, everyone. Um, I want to go over some topics here that are related to Module 1. One of them, this is more a review than anything else. Uh, this is about completing the square. Okay, so let's complete the square. And one of the things we need to know that is because we're going to be dealing with circles. So let me work this backwards. Suppose you have this. Again, I'm going to do this backwards. So this is equals to this. When you FOIL it, you end up with this. Okay. Now, this right here came from this. Now, this one is called a perfect square. You can see they have x plus 1 raised to the second power. The question is, how do we go back to this? Okay. So my goal is to take something that looks like this and complete the square in such a way that I end up with something in parentheses, x plus a number or minus a number raised to the second power. So that's what I'm going to show you. How do we come up with that number? Okay. So I'm going to use the same example. And notice that what makes this a perfect square is the fact that this here is a 1. Now I'm going to show you how do I get that 1. So I'm going to take it to the next level. Okay. So there you have this. Suppose you had this. And they tell you create a number in that little space there in such a way that you end up with a perfect square. So the process is that you take the coefficient of x, which in this case is 2, and you will always divide it by 2, and then you square it. And notice that I generated a 1. This 1 will guarantee now that this trinomial is a perfect square. Now, how do I get that x plus 1? Well, instead of writing x squared, I just write x. The sign is from here. And then the number 1 is actually the square root of this number. So there you have what we call a completing the square. Let's do another one. Okay. So you have, let's say you have this here. And let's say that you don't know what the number is. So here it is. We're going to take the 4, coefficient of x, always divided by 2, square it, and what do we have? 4 divided by 2 is 2, and when you square it, you get 4. So now you get a 4. But this way, now it's going to be parentheses, square. So let's talk about what we put in the parentheses. So instead of writing x squared, you write x. The sign that goes here comes from this guy, so we put a plus. And then the number that follows there is the square root of 4, which will be 2. So now you have a perfect square. Now, I can show you that if you were to expand this, you will get back this trinomial. Okay, let's do one more. X squared plus these two fractions. I mean, it doesn't matter what number it is. Suppose you have this, right? Now, this time, you take the 3 and you divide it by 2. And guess what? It doesn't simplify to a single nice number. So this time, when you square it, you get 9 over 4. So this is the number that will go here. So how do we write this in a square form? Well, the plus goes there. The x squared, instead of writing x squared, you just write x. And now the number you're missing is the square root of 9 over 4, which is 3/2. And then it goes here. And there it is. Now, how do we simplify this and use this when we're dealing with circles? Okay, so we're going to get to circles. Now, this is the equation of a circle that is centered at the origin. The radius is 4. I will tell you how I got that radius. Notice that r squared is equals to 4. Then you take the square root of the other side, and this is where you get 2. So the radius is 2. So now it's centered at the origin, and now we have this circle. Radius is 4, okay? So this is 4, distance here is 4, 4, 4. Now, how do we write this in a more standard form? Let me show you. This is the standard form of a circle. Okay. Oops, I don't want to write equal. I want to write minus. Okay, equals to r squared. What you're looking at right now is the standard form of a circle. Now, the one that we did before, I could have written it this way also. Now, of course, I don't have to. Okay, here's the center right there, and the radius is 2. But unfortunately, not all circles are centered at the origin. Now, in this case, you might be wondering what is h and k. Well, the center is h and k. Okay? And that, notice, I want you to mention something here. This is negative, right? That's part of the formula. So for instance, if you had a circle like this, and I ask you, what is the center? Well, the center will be 2, 3. Now, you may be wondering, what happened to the negative? Well, that negative actually belongs to the formula. And notice that when I wrote the center, I wrote it here without the negative. Okay. Now, the radius is 5. Even though you see 25 here, the 25 is actually r squared from the formula. You see? Where's the formula? Oh, there it is. You see this? So when you see 25 r squared, that means that the r, the radius, is 5. Okay? No, now look what happens when I do the following. Suppose I change this to a plus. It's still a circle, but the radius, the center now is not 2, 3. It's going to be negative 2, 3. Okay? Let's do this too. Let's change this to a plus. Well, now the center is negative 2, negative 3. And there you have it. Okay? So this is as easy as that. Now, in Alex, they might ask you to actually graph it. Okay? So if they ask you to graph it, okay, they might give you something like this. They will ask you, I don't know, let's do 16, okay? And let's do it like this, where one is positive and one is negative. So that you can see there are many different cases. So this means that r squared is equals to 16. Well, what is r? R is 4, okay? What is the center? The center in this case will be negative 1, 2. Notice that we do the opposite signs. Okay, this is where you have to be very careful with the signs. So now, how do we graph it? Perfect. So this is what we do. Go to the center, negative 1, 2. So this is the center. Then what you do is use the radius. The radius is 4. So you're going to go, this distance is 4, that distance is 4, 4, 4, and there you have your circle. Now in Alex, you're going to have all the features available to you so that you can actually graph it. Okay? So don't panic when you see this. One thing that I want to mention, what makes it a circle? First of all, we need a plus in the middle. Without it, if you have a minus in the middle, you don't have a circle. You have something else. Okay? You will have an ellipse, but we're not doing those. We're doing circles. So the plus has to be in the middle. What else does it make it a circle? The fact that this is square, and this one is also square. That's what makes it a circle. And the last thing is that the radius must be positive. In this case, r is 4, which is greater than 0. Why? Because the radius has to be a positive number. Now, what happens when the radius is 0? Suppose the radius was 0. Well, in this case, you get a dot. Okay? You don't get a circle. You just get a little dot because there's no radius. So the radius has to be greater than 0. That's what makes it a circle. Okay? Let's do another one. Oops, I have to go back. Well, let's do it here. Let's do this one. Suppose you have 2 times x minus 2 squared plus 2 y plus 1 squared equals 2, let's say 32. Okay? So what happens now? So before you do anything, the first thing you're going to do is you're going to divide this by 2. And so what do we have now? There it is. You see? Now what's the center? Center is going to be 2 comma negative 1. What's the radius? Once again, is 4. And then you can graph it. Okay? So there you have something that is doable. Don't panic when you see this. This looks more difficult than what it is, but it's not. Now, what I'm going to show you is how do I apply the concept of completing the square and why I did this first. The reason why I did that first is because we need to complete the square in some cases. For instance, look at this example. Okay. Let me write this down first, and then we'll talk about it. Look at this. The first thing you see is like a bunch of numbers, letters, and 32 at the end equals 0. And they're going to ask you, write this equation in standard form. And they're going to ask you, is it a circle? 2, they're going to ask you, if it's a circle, then tell me what the radius is. Now, notice that in the other cases like this, it was easy for me to see what the circle was because it was already in this form. Okay? Well, the one that I'm showing you now is not. So how do we make this happen? So now we're going to take a bunch of steps. Now, the first thing is, notice that we're going to divide this by 2. This is going to make it a lot easier for everyone. Okay? So what do we have now? X squared. And the other thing I'm going to do is that I'm going to group the x's closer together. This will be 5x. And also, I'm going to create a little space. That little space is this little space. Okay? So don't panic. Then I'm going to write y squared plus 10y, the little space, then equal, and this is the part that is getting little too tight. This is what? 16, correct? But that 16, I need to move it to the right-hand side. And when I do that, it becomes negative 16. Okay? So now we have to keep track of things. This is negative 16. Okay? So now we need to complete the square in terms of x and also in terms of y. So here it is. Let's see. 10. All right. So this is going to get a little bit crazy. So 5 divided by 2. What did I get this 5 from? From here. Doesn't simplify into something nice. So we get 25 over 4. Now at this moment, I have added 25 over 4 to the left-hand side. So I have to do the same to the other side. Okay. In order for me to maintain equality. Then I do the same for the 10 over 2. Where did I get the 10 from? From here. Square. So this will be 5 squared is 25. So I get 25. But don't forget to also add 25 to the other side. Okay. So we have a bunch of things to keep in mind, to keep in order. This is like accounting. A bunch of numbers to keep up. So now I'm going to write this. And hopefully I can come up with a number there. Now, what goes inside the parentheses? Well, I'm going to write x. Then I'm going to write the sign that goes here. It goes here. What is this number? Well, what is the square root of 25 over 4? is 5 over 2, okay? Then here on the other side, I write y plus, what's the square root of 25? 5. Now, this is what I have to work a little bit harder. 16, 25 take away 16 is 9, okay? But 9, I have to add it plus 25 over 4. So I'm going to do that here. 9 plus 25 over 4. Now, this might be a good idea to review adding fractions. So what I'm going to do, I'm going to show you a shortcut. You multiply there, that will be 36 plus 25 divided by the same denominator. Okay? So what do we have? We have 36 plus 25. That gives you 61 over 4. So this is what I get here. Okay? So I get 61 over 4. Now, this is not pretty. And I did this on purpose because I don't want you to think that always the numbers that you work with are always nice. Sometimes you get ugly radiuses and ugly centers, but they exist. So I'm going to erase some of this stuff because I need to show you something else. Now, since you have done all of this, now I can tell you what the center is and what the radius is. So the center is going to be careful here, -5 over 2, comma, -5. That's my center. And the radius will be the square root of 61 over divided by the square root of 4, but the square root of 4 is 2. So there you have your radius. Okay? So I want to stop the video here. I don't want to continue. And the next time we meet, we're going to do more of this. Okay? All right, guys. Thank you.